Hello guys, this is Sushant. So welcome to your channel, which is Sci Engineers. We have meeting after a very long time. So I hope you had a wonderful semester and will be continuing to help you in your studies for this semester also. We are associated with the Samartha Vidya classes, which is group tuitions for the engineering students and science students. For the current semester, that is your Sem 2, we conduct lectures for your applied mathematics, SPA and engineering. So if you want to know about us, then you can do so by emailing us at samarthavidya@gmail.com, or you can visit our Facebook page, which is for Samartha Vidya. The link for the Facebook page and the email address is given in the description below. We are thankful to all other guys who have been sharing our videos, commenting on our videos, and also liking our videos. This has been inspiring us to make more videos for you and indirectly help you. So we would be hoping to get more likes, more shares and more comments for the videos which we'll be uploading for this semester also and the other semesters. So do share, do like and do comment. So in today's video we're going to start with the topic which is for your differential equations for the first order, first degree. So let's get going. So coming to your semester 2 mathematics section, that is applied mathematics, the first topic which we are going to deal with is your differential equation for the first order, first degree. So let us try to understand what basically differential equations are. Differential equations are those equations which are formed by the differential terms, like your derivatives of your dependent variable with respect to some independent variable, which is nothing but your dy by dx, or the higher order terms of it, and it will be also comprising of the functions of your dependent variable or independent variable. So together these equations form the differential equations. Now whenever you are solving your differential equation, you have to first of all understand the two main terms which are associated with it, that is the order and the degree. So order is nothing but the highest derivative term which is present in the equation. So in this case you can see that the highest degree term or the highest order term which is present is your 2, that is the double derivative term which is present. So your order of this equation is going to be 2. Then coming to the next one, which is the degree. So degree is nothing but the degree of the highest order term which is present. So you can see that the highest order term is 2 and the degree to it is 3. So that is why the order for this equation is 2 and the degree is 3. So that is why you can see that we have written that the differential equation which will be based on your first order and first degree. So once you have understood the degree and the order's definition, then coming to the topic's name, that is differential equation with first order and first degree. So in this particular topic, we are going to be solving differential equations which will be only consisting of the first derivative term, and the degree to those derivative term will be 1. So there are various methods to solve this particular equations. We have already dealt with the solving part of this in your 12th standard in the differential equation chapter. So we'll be continuing henceforth from there to solve the differential equations in various other methods. So the first method which we'll be dealing with is called as your exact differential equation. So let us try to understand what basically exact differential equations are. So the equations basically, when you are taking derivative of it, and if you have not cut or cancelled any of the terms after taking the derivative, then whatever is the resulting differential equation is your exact differential equation. So repeating myself, exact differential equations are nothing but those equations which have been taken the derivative of it, you have taken the derivative of it, and you have not reduced down by cancelling of any of the terms present in the differential equations, or not cancelling even the constant terms present in it. Then the resultant differential equation is called as your exact differential equation. So this is just the rough understanding what exact differential equations are. So the definition which we just discussed is not going to help you to determine whether the function is going to be the exact differential equation or not. So for that we have some of the formulas which are going to be based on it. So let us try to understand in which form we require the differential equation in. So we know that we are going to be solving your first order first degree equations. So your first order first degree equation in general will be of the form dy by dx is equal to some function of x and y. Now this particular equation can be written in this form also, that is m dx plus n dy is equal to 0, where you can have this m and n which are going to be functions of x and y. So whenever you have to check the condition for exact differential equation, then in that case you require the equation in this form, that is m dx plus n dy is equal to 0. Then after that you go for the condition for your differential equation, the sufficient or the minimum requirement for the differential equation to be an exact differential equation, which is nothing but your dou m by dou y should be equal to dou n by dou x. So if this particular equation holds, that is the derivative of m with respect to y and derivative of n with respect to x partially, if this particular equation holds, then only the terms or the differential equation will be called as your exact differential equation. You will be knowing this particular notation over here, that is your partial derivative terms, that is partial derivative with respect to y and partial derivative with respect to x. So if you are not familiar with this particular term, then you can just go and watch the videos which we have already uploaded for your partial differentiation. You can just go and browse through it to understand how to find the partial differentiation. So from this particular problem, we will be trying to understand how to verify whether the equation is an exact differential equation, and if it is an exact differential equation, then what are the methods to solve it. So we have this particular question which is dy by dx plus some function is equal to 0. So first of all, we have to bring it down to your m dx plus n dy is equal to 0 form. So once you bring it down to that form, you can see that the equation can be written as y into cos x plus sin y plus y into dx plus the dy term will be sin x plus x cos y plus x dy is equal to 0. It's basically we are cross multiplying it to find the equation in the form of m dx plus n dy. So from this you can see that this term is your m term and this is your n term. Once you have found your m and n, then you have to just find the partial differentiation of it. So if you are having your m term, then it is partial differentiation with respect to y. So you will be finding your dou m by dou y, which is nothing but differentiation of m with respect to y partially. So you'll be getting that term as the y term over here, so it's going to be cos x plus it's going to be cos y plus 1. So this is your dou m by dou y. From here you will be getting your n term, that is dou n by dou x. So dou n by dou x is partially differentiating n with respect to x. So you will be getting that as cos x plus cos y plus 1. So from this you can see that your dou m by dou y is equal to dou n by dou x. So from this you will be getting the equation which we were solving as your exact differential equation. So once you have proved that the equation is an exact differential equation, then after that the solution which will be present, or the solution which is going to be there, is given by this particular formula, that is integration of m dx keeping your y constant. So while you are integrating this term, you will be keeping your y constant and you will be integrating it with respect to x, plus you will be finding the integration of your n, and while doing so you have to have no terms of x. So you should avoid all the terms which are present in x in n and find the integration with respect to y. This thing will be equal to the c, which is the constant of integration or just a constant term present. So After this, you will be just substituting. So it is m dx. So m is nothing but it is integration of y cos x plus sin y plus y with respect to x plus integration of n dy. So it is no terms of x. You can see that there is a sin x present, there is a x cos y present, and x present. So all the terms which are present in this particular n are related to your x only. So there is no term without x, so that is why it will be 0 dy is equal to the constant c. Now while integrating, you have to remember that the y term is constant, or the functions or anything which is related to y is going to be constant. It's going to be considered constant. So it is y cos x. So since y is constant, so it is integration of cos x, which is nothing but y into sin x plus its sin y term. Since y is constant, so sin y is also constant. So integration of that is going to be x sin y. Again, it's a y term is constant, so it's going to be plus xy. This thing will be equal to the constant c. So this is nothing but your solution of your differential equation. So this is how you will be solving your exact differential equations. So in this, you have to just remember two things, that is, the differential equations will be exact only when you will be having the condition which is dou m by dou y is equal to dou n by dou x. And before this, you have to bring it down in the terms of m dx plus n dy is equal to 0. Then you will be checking your exact differential equation condition. Once you have proved that it is exact differential equation, then you can go for the formula, that is integration of m dx y constant plus integration of n dy no x. Now this thing can be reversed. It can be also written in this format, that is integration of n dy with x constant plus integration of m dx with no y is equal to c. So either of the equations can be used. So depending on which is going to be the easier way to find the integration, because integration is quite difficult. If the integration of, let us say, n is quite difficult, then you will be going for the integration of n dy this term, because most of the terms present in n will get nullified. If the integration of m is going to be difficult, then you go for the second one. So this is how you'll be finding your solution for your exact differential equation. So in the next video, we will be seeing the methods to reduce the equation into an exact differential equation. Like if you do not have the differential equation as exact, then you can reduce it down to an exact differential equation by just multiplying the integrating factor. We'll be seeing those terms in the next videos. So to get the regular updates, you need to just subscribe to our channel, like our videos, share our videos, and comment on our videos. The sharing and the liking of the videos will help us make more videos for you in the coming future. So we are associated with the Samartha Vidya classes, which is group tuitions for the engineering and science students. So if you want to know about us, about our batches, you can do so by inquiring at samarthavidya@gmail.com, or you can visit our Facebook page, which is for Samartha Vidya. The link for the page and the email address is given in the description below. So for now, keep learning, keep watching, and happy learning. Do not forget to subscribe. Thank you. Bye.